In this example, we'll let A be the vector 1, 2, negative 3, B the vector 0, 2, 4, and C the vector 5, negative 1, 3. We want to use these three vectors and find the following. A dot B, quantity times C, A dot the quantity 2 times C, and the magnitude of B squared. First, we'll find the value of A dot B, quantity times C. A dot B is a scalar, and so here what we're ultimately going to do is find a scalar multiple of C once we have the appropriate scalar given by A dot B. So our first step is to find the dot product of A and B. Using the component forms that were given, we see that this dot product will be 1 times 0 plus 2 times 2 plus negative 3 times 4. And therefore, we have 0 plus 4 minus 12, which will be negative 8. So A dot B will be negative 8. And therefore, our desired product will be negative 8 times vector C. And this is scalar multiplication. And so we're going to multiply each component of C by negative 8. And this will give us the vector negative 40, positive 8, and negative 24. So A dot B, quantity times C, will be the vector negative 40, 8, negative 24. Next, we'll find the product A dot 2 times vector C. Using a property of dot products, we can take the scalar of 2 and move it outside of our dot product. So this would be 2 times A dot C. So we have a simpler dot product to compute, and then we'll just scale that by 2 at the end. So here we'll need to compute A dot C. Looking at the component forms of A and C, we have that dot product being 1 times 5 plus 2 times negative 1 minus 3 times 3. That would be 5 minus 2 minus 9. So here we have a dot product of negative 6. We then multiply that by 2 to get negative 12. So A dot, the quantity 2 times C, will be negative 12. Notice that we could have first scaled C by 2 and then taken the dot product with A, and that would have also yielded negative 12. For our last calculation, we want to compute the magnitude of B squared. Here we could certainly compute the magnitude of B and then square the final answer, but we could also compute this using dot products. By a classic property of dot products, the magnitude squared of a vector is equal to that vector dotted with itself. So in this case, magnitude of B squared would be B dot B. We can then compute this dot product using the component form of B. So this will be 0 times 0 plus 2 times 2 plus 4 times 4. So of course is 0 plus 4 plus 16, or 20. So the magnitude of B squared is equal to 20. Next, we're given vectors P, Q, and R, where P is the vector 7, 0, 2, Q is the vector negative 2, 2, negative 2, and R is the vector 0, 2, negative 3. We then want to find the following expressions. First, R dot P, quantity times Q, and the magnitude of P squared. You can pause the video and try this example yourself, then resume the video to see the solution in a few seconds. For the expression R dot P times Q, we first want to find the dot product of the vectors R and P. So that would be 0, 2, negative 3 dot 7, 0, 2. We compute that dot product and find that the value is equal to -6. We then scale the vector q, which is -2 to -2, by -6, multiplying each component of q by -6, we obtain the vector 12, -12, 12. So this is the vector r dot p, quantity times q. To find the magnitude of p squared, we again take the dot product of the vector p with itself. So 702.702. This would be 7 squared plus 0 squared plus 2 squared, or 49 plus 4, or a 53. So the magnitude of p squared would be equal to 53.